So, just like with fractions, adding and subtracting rational expressions with the same denominator is easy. If we have the same denominator to begin with, we just add or subtract the numerators. So these two rational expressions have the same denominator, 5y. So we can add them, keeping that same denominator, 5y, by adding the numerators, 3x plus 4x. Those are like terms, so we can combine them. We end up with 7x over 5y. Can I simplify that? Well, I have different variables in the numerator and denominator. Nothing I can do with that. 7 and 5 are both prime numbers. They have no common factors. So I cannot simplify that at all. This next example, again, we have the same denominator, 4x plus 1. Notice we're subtracting. So we can do this subtraction. We'll end up with that same denominator, 4x plus 1. And then we'll just subtract the numerators. So 11x squared minus 7. And those are not like terms, right? 11x squared and 7. Not like terms, I cannot combine them. So now I'm done doing subtraction. Can I simplify that at all? Well, 11x squared minus 7, if I was going to factor that, it would have to be a special form. But 11 and 7 are not perfect squares, not perfect cubes. I cannot factor that numerator, so that's it. I can't simplify that. This next example, I've got a ton of space, which suggests we're probably going to be able to do some simplifying. So again, we see the same denominator in each of these two fractions. So we can add just by adding the numerators. So our denominator stays the same, 6x squared minus x minus 15. And we will add the numerators. So x squared minus 7x plus 2 plus x squared plus 2x minus 14. So we'll actually do that addition in the numerator now. No work in the denominator. That's still 6x squared minus x minus 15. In the numerator, we're adding polynomials. Associative property says we can just drop those parentheses and combine like terms. So we'll have 2x squared minus 5x minus 12. Okay, so now we're done with adding, but we might think, well, can I simplify this? We don't know. We'll need to try to factor our numerator and denominator. Let's see. Our 2x squared minus 5x minus 12. That's a quadratic trinomial. The leading coefficient is not 1. We'll use the AC method. We have AC is negative 24, B is negative 5. So we'll keep our 2x squared and our negative 12. When we try to split up the middle term, we want two numbers that multiply to negative 24, add up to negative 5. I think we'll split that up as a negative 8x plus a positive 3x. First row, our common factor is 2x. We need to multiply that by an x to get 2x squared, by a negative 4 to get negative 8x. Our x on top, we need to multiply that by a positive 3 we get 3x. And then 3 times negative 4 really does give us negative 12. So our numerator factored as x minus 4 times 2x plus 3. Okay, let's try to factor our denominator now. We've got a 6x squared minus x minus 15. Our AC is negative 90. Our B is negative 1. So we'll copy our 6x squared and our negative 15. We want to split up the middle term using two numbers whose product is negative 90 and whose sum is negative 1. You may spot this immediately, or you may want to use a calculator to help you find it. We'll use 10x negative and positive 9x. Right, negative 10 times positive 9 is negative 90. Negative 10 plus positive 9 is negative 1. Okay, so now we're looking for, in our first row, our least common multiple, I think, is a 2x. And then 2x times what is 6x squared? 2x times 3x. 2x times negative 5 is negative 10x. 3x times 3 is 9x. And then 3 times negative 5 really is negative 15. So our denominator factors as 2x plus 3 times 3x minus 5. We can cancel a common factor of 2x plus 3, and we're left with our simplified sum being x minus 4 over 3x minus 5. So if we can simplify, it ends up being a little bit of a production. Okay, one more of these. We have x squared plus 6x plus 9 over x to the fourth minus 81 minus 12x over x to the fourth minus 81. Same denominator, so we'll keep that denominator, and we'll subtract the numerators. X squared plus 6x plus 9 minus 12x. Doing the subtraction in the numerators? Well, there's only one term in the thing we're subtracting, so we don't need to mess around with distributing a negative sign. We can go ahead and combine like terms. We'll have x squared. 6 minus 12 is negative 6, so minus 6x plus 9. And then our denominator, x to the fourth minus 81. We'd like to simplify, so we need to factor our numerator and denominator. X squared minus 6x plus 9. We actually recognize that as a perfect square, right? This is x squared. This is 3 squared. This is negative 2 times 3 times x. So this is going to be x minus 3 squared, or x minus 3 times x minus 3. Our denominator, x to the fourth minus 81, that's x squared squared minus 9 squared. That factors as a difference of squares. X squared minus 9 times x squared plus 9. And then x squared minus 9 is another difference of squares. So that'll factor as x minus 3 times x plus 3. And then the x squared plus 9 just follows along. The sum of squares there is prime. So we're left with, in our numerator, and x minus 3 times another x minus 3. In our denominator, an x minus 3 times an x plus 3 times an x plus 9. An x minus 3 cancels out, and we're left with our simplified fraction as x minus 3 over x plus 3 times x squared plus 9. And again, probably we're going to leave that denominator in factored form.